And so you need to recognize that this is actually 1 over root 3. So multiply here, the top and bottom, by root 3. And then you get negative root 3 on top, and on the bottom, root 3 times root 3 is 3, right? So what angle is that? Sorry, someone had already said it. Negative pi over 6, right? So, or negative 30 degrees. What am I doing? Pi over 6 or negative 30 degrees. I hope you all really understand. I don't like giving that quiz over the unit circle like I did, but I mean, I'm hope that I'm selling you on it, that knowing it is going to make your life a lot better. Okay, let's do another one. Just do it here. How about inverse tangent of 435? Not degrees, just 435. That's saying where on the unit circle, looking only in the first and fourth quadrants, right, is the ratio of the y divided by the x equal to 435. You no longer have the problem we had a little while ago, right, Maximus, remember with the sign? Like, we couldn't be bigger than 1, right? We couldn't have a number bigger than 1 here, but with tangent we can, because think about the tangent function, right, where this all is coming from. Right, it goes like this. So we're saying at what angle do you get to 435? Well, shit, I don't know, right? But your calculator does. Your calculator is going to be able to tell you this. So do inverse tangent of 435, and you're going to get either radians or degrees here. What do you got? 4.57? Oh, 1.57 radians. And in degrees, it's going to be really close to 90. What is it? 89.87 degrees. Does that make sense to you all? Look at this picture. This is the tangent function, right? This is pi over 2 right here, where we have a vertical. Pi over 2 is 90 degrees, right? We have to be pretty damn close to 90 degrees to get an output of 435, right? All right, I think y'all are good. We're moving on. The cancellation property. Careful. The whole idea behind an inverse function is that it undoes the original function, right? That's the whole concept. You start with, that picture I drew a second ago. If you start with something here, like start with some x value, send it through the function f, and then send that back through the inverse function, it should go back to exactly where it came from, right? So if you ever put a function together with its inverse, they just kill each other off, yes? Like that's the idea. That's what the cancellation property is saying. So, do you think this is true? If I take sine, and inside of the sine I put the inverse function, and inside of that I put x, do y'all think that I'm going to wind up getting x? Yeah? That would be, the picture of that looks like this. X first goes into the inverse function. So it's actually like the x starts here. It goes through the inverse function, through the inverse sine, and then whatever that answer is, it gets sent back through Does it seem reasonable that going through that loop, it should come back as x? X goes in to the inverse, then through the irregular function, and then comes out unchanged. Does that seem reasonable to you? Y'all okay? Yes? What? No? It's like a car wash, okay? This is like a car wash. I'll do it this way. Here's a car wash, okay? Wash. Wash tub. There we go. All right, so we send in a value x, right? Clean. This is going to be a dirty car, right? We send in this dirty car. Comes out over here, dirty. Right? Comes out over here, clean. Right? The idea of an inverse function is another car wash over here where you take your clean car and it spits it out back as a dirty car, right? That's the idea of an inverse function. This is f. This is its inverse. What this is saying is that let's start off with the car on this side. The car starts here as clean. Okay? Send it through the inverse function, comes over here dirty. Now send it through the original car wash, it comes back clean. That's what this is saying. Start, dirty the car, clean the car, comes back clean, right? Look at that. Does that help? Yeah? Okay. Look at that versus this. Sine inverse of sine x equals x. Do you buy that? So who gets the x first? Sine gets it first, and then it gets sent through the inverse. So that's this picture. Start dirty, go through the car wash, go through sine, get clean, then go through the inverse sine back to dirty. That make sense? So those are different, aren't they? I mean, the way that things are happening is different. Where we're starting is different. Here, the inverse gets it first, then the original function. Here, the original function gets it, then its inverse gets it, and then it comes back. So those seem reasonable to you? Yes? Okay, but I put here what? I put careful, right? I put careful. And I'm going to show you why you have to be really careful with these. So right now, I would like for you to put above this question mark, right? Is this true? It seems like it is. The car wash seems like it's going to make things okay, right? Yes?
So both of those are for the cancellation property?
Yes, this is called the cancellation property because what's happening is that basically these two functions are canceling each other out. It's almost like this sine function eats that one, they all go away, and you just have x, right? Here, this inverse sine and sine kill each other off, and you just have x. But I'm telling you, be careful because it, watch, okay? Watch. All right, example. Let's start with this one. How about sine inverse of sine of pi over 4? Let's start with that. Well, if you believe the cancellation property, if you believe this is true, the answer should just be what? Pi over 4. Okay, and I'm going to tell you right now, that is true. Let's see why it's true. Let's see why. Let's start and do this piece by piece. What is sine of pi over 4? What is it? Root 2 over 2. That's root 2 over 2, right? So this is saying, hey, go to the y coordinate, go to pi over 4 on the unit circle, go to the y coordinate. It's root 2 over 2, right? So this really means sine inverse of root 2 over 2, yeah? That's what that means. Now, we just did this problem, right? This is saying to us what? Where on the unit circle, where do we have to cut off? What do we have to cut off? Which quadrants get cut off? 2 and 3 get cut off. Okay, and now it's saying to you, at what angle, right? At what angle is your y coordinate root 2 over 2? 45, right? Which is pi over 4, right? Which is the answer, yay, right? So it seems like this works, yes? Yeah. Let me do another one. Just because it worked once doesn't mean it always works. Does anyone have a question on that? Right now, this is looking good. Like, we're looking at this, we're like, hell yeah, this is awesome, right? And then you get this. sine inverse of sine of 7 pi. No, let's do 7 pi over 4. 7 pi over 4. There you go. If you use the cancellation property, what are you going to tell me the answer is? 7 pi over 4. Right? That's what you're going to tell me the answer is. 7 pi over 4. And that's wrong. Because of the restriction. See, if we try this, right, what is this? Okay, well, sine of 7 pi over 4. So you have to know where 7 pi over 4 is, right? Where is it? Where's 7 pi over 4? It's right there, isn't it? That's 7 pi over 4. And you want which coordinate? The y. That's negative root 2 over 2, right? So that's what this is. This is sine inverse of negative root 2 over 2, right? But now, see, you have this domain restriction, right? This has a restriction. You're only allowed to look in the first and fourth quadrants, right? And you're trying to figure out where the y coordinate is negative root 2 over 2, which is the same point as that one over there, right? But you're not allowed to get there by going all the way around. You can only get there by doing this little rotation, which is what? Negative pi over 4. So the correct answer here is negative pi over 4, not 7 pi over 4. Do y'all see how that's a little tricky? So my advice to you is this. Work it out the way I worked them out, okay? Just work them out. Figure out what this is, right? And then do what we did before and get your answer. Just do that for each one of these, all right? Let me give you another one. I'm going to switch the order. Notice that the inverse signs were on the outside here, and the signs were on the inside. Let me switch it. What if we do sine, and then sine inverse, and inside the sine inverse, I need to put something in here, right? What goes into inverse sine functions? Angles or numbers? Numbers, right? Numbers go into this, angles come out. So how about I do, there we go. If you believe in the cancellation property, what should the answer be here? If you believe in the cancellation property, this kills this, our answer should just be? No, if these two kill each other, our answer should just be 1/2, right? I wonder if it is. Right, is it? Let's see, let's go slower. Now you had this right. This was what? You said that's pi over 6, right? You're saying where on the unit circle in the first or fourth quadrant is your y coordinate 1/2? Okay, and now this is saying what's the y coordinate at pi over 6? What's the y coordinate at pi over 6? 1/2. Okay? It worked, didn't it? It worked. So, you know how I said be careful, right? The only times you ever have to be careful are when the sine inverse is on the outside. If the sine inverse is on the inside, you should be fine. Now, you still have to be a little careful with it. Let me give you one where I could still get you, all right? How about this? How about sine of sine inverse of 4? Don't tell me the answer is 4. Why? What's sine inverse of 4? Right, Maximus? This is kind of like the one we did, right? Was it 4 or 5 or 3? I can't remember. 3. It was 3? Remember Maximus was trying to do sine inverse of 3? So we're saying like where on the unit circle is the y coordinate here? 4? Not happening, right? This is undefined. So you can't just tell me that this is 4. So my advice to you is the cancellation property is nice in calculus. When you get to calculus, we'll use this property a lot. but we will assume that everything is like within the domain restrictions that we need for it to work. In this class, just grind out each piece. Just figure out what each piece is. This is undefined, so you know what? This whole thing is undefined, all right? How are we doing here? You all right? Let's do this. I'm going to switch to cosine inverse of cosine of 5 pi over 8. Okay, please pay attention to this problem. I know it's late. It's already the end of the week. You ready for the weekend? I'm just kidding. Didn't I tell y'all the other day it was Monday or something?
Yeah.
I said, y'all are acting like it's Monday, right? Did I do that last week? Yeah, I did that last week, didn't I? All right. Don't just go crank out the cancellation. Don't just be like, oh, this one kills off this one, the answer is 5 pi over 8. Don't do that. So first thing we do is figure out what's cosine of 5 pi over 8, right? Well, you shouldn't recognize that angle, right? 5 pi over 8 is not an angle you recognize. And I know that you want to go to your calculator, but I just want you to think about this. I think it's more constructive if you think through what's going on here. Cosine gives you which coordinate on the unit circle? I'm looking at this right now. The x coordinate. So I need to go to the angle 5 pi over 8. Where the hell is 5 pi over 8, right? Where is it? Well, what's 5 divided by 8? Do that on your calculator. It's 5 divided by 8. What is it? 0.625 pi, right? Right? 0.625 pi is where we are. What's this? Straight up. No, I'm saying the angle. What's this angle? Pi over 2. That's half of pi, isn't it? Half of pi. This is 0.625 pi's. So is that this to the left or to the right of this? A little bit to the left, right? This is a little bit bigger, right? That's not quite, 1 pi. 1 pi is here, right? Half of pi is there. So this 0.625 is somewhere in between the two, yes? Okay, I don't know where it is, but I can tell you it's in the second quadrant. Okay, so that angle right there is 5 pi over 8. Now I realize I'm going seems tedious, but just follow through. I've analyzed, I know what quadrant this angle's in. It's in the second quadrant. Got it? I want the x coordinate. I want the x coordinate, don't I? So the x coordinate is whatever this is. Right? Whatever that x coordinate is it positive or negative? It's a negative, right? It's a negative because I'm in the second quadrant. So this right here, cosine inverse, this right here is some x coordinate, right? And this x coordinate is negative. Yeah? And now what I want, this always confuses students. I know it's confusing. I just want to play it again, play it over. I figured out what quadrant that angle was in, right? And then I said cosine of it, so now I want the x coordinate at that angle. I'm in the second quadrant, so I know that the x coordinate that I'm going to have there is negative, right? What is this asking? What is cosine inverse of x asking? Or what is it asking us to do? It's saying for us to find the angle, right? Figure out what the angle is, right? What angle do you need in order to have the x-coordinate be this, right? But you can only live where? Well, in terms of cosine inverse, where's the only place you can live? First or second, right? You're not allowed down here. So wouldn't the angle that would give you that x-coordinate, which is in the second quadrant, wouldn't that angle still be the same angle, 5 pi over 8? Isn't it the same angle? It is, right? So our answer here would be 5 pi over 8. I'm going to have to do another one of these, or a couple of them, for you to figure out what's going on here. I think I need to show you one that it doesn't behave this way. I know when students don't understand this, what they do is on the test, they just guess. They say, okay, I'm going to go for 5 pi over 8. Hopefully it's right, you know? But I'm just showing this to you for the first time. So, you know, let's kind of slowly absorb this. Let me try the same problem with sine inverse and sine and see what happens. So sine inverse of sine of 5 pi over 8. All right, this is usually where the wheels come off right here for a lot of students. Right here, this problem right here. All right, so the first thing I'm going to do is figure out, you know, that 5 pi over 8 is not a common angle. So I got to figure out where it is. Well, we already did that, right? So we know where we are here. Right here. And sine of that angle is which coordinate? The y coordinate, right? So my y coordinate is here. And I'm trying to figure out, right, like this right here is that y coordinate. So let me write it right here. This now becomes, I want sine inverse of that y coordinate, whatever it is. You with me? But when we do sine inverse, we can't live in the second quadrant, can we? Which means that I still want to look at that y coordinate, but I can't be over here. So where is it really? Where would I have the same y coordinate as I do right here? In the first quadrant, right there. That would have the same y coordinate, wouldn't it? These two have the same y coordinate. See, because when I'm looking at this problem here, sine inverse, I'm not allowed over here. Yeah? At what angle, what this question is asking is at what angle between negative pi over 2 and pi over 2 do I get that y coordinate? Do y'all see the angle? It's that right there, isn't it? That's the angle. Do you know what it is, though?
3 pi over 8?
How do you figure that's 3 pi over 8? What is that question?
4 pi over 8 is pi over 2, so it's going to do that.
Okay, so there's a couple of ways to do this.
Across the axis.
Yeah, there's a couple of ways you can look at this. The way I like to do it is this. I mean, you can use symmetry. I like the symmetry. I need to back up, make sure everyone understands how we got to this point, because I'm looking out there and I'm seeing some faces of disgust. Figuring out where this angle is, 5 pi over 8. I'm in the second quadrant. We good with that? Okay, I want sine of that angle. So that's just the y coordinate there. Yes? That entire inside is just some y coordinate. Boom. Now start the whole problem over. If I tell you I want sine inverse of some y coordinate, you're only allowed to look in the first and second quadrants and find the angle that goes with that y coordinate. So you say, oh, that y coordinate, we really are talking about this. And I want that angle. Now to find that angle, I have to use the 5 pi over 8. So look. Our original angle was from here to here. That was 5 pi over 8. Right, that's that. We want to be that same distance here, we want to be this way. So the way I like to look at it is if I can figure out what this is, right, from here to here, won't that be the same distance as going up like this and drawing it on this side? So what's all the way? From here all the way, what's that? Pi, right? So I'm going to take pi, and then I'm going to subtract from it this angle right here, 5 pi over 8. And that will be my angle. And then you get a common denominator, 8 pi over 8 minus 5 pi over 8. And that gives you your 3 pi over 8. So if you just do it a different way, I'm okay with that on a test. All right? But that's the way I always do it. I always say, okay, whatever this was, I need to subtract that angle, and that'll give me this difference, and that's what I need over here. So the answer to this is 3 pi over 8. That's tricky, huh? A little tricky? All right, let's see how you do with the homework on this, okay? Let's see. We'll come back with questions. Your homework just kind of like dump everything before chapter 8. We're good. We got through the test. I'm happy, you're happy. Let's just start clean slate, chapter 8. The homework for this is due before we meet next class, all right? So we're back on kind of task. Yeah? See how it goes. If you have questions next class, you have some questions. Let me see here. Did I staple both of these together? Oh shit, hold on. On the homework, shoot, I just realized I didn't get to these here. On the homework, stop at number 15. So homework, do 1 through 15. 16 through 20, skip that for now, all right? Just do 1 through 15. All right, I'm going to hand your test back if you want it. All right, so y'all go ahead and, yeah, that's good. Let's see, Farah, if y'all could come grab these when I call you. And I never put them all together, so I'm going to have to do this twice. Gabriella, Gaza. Let's do this. The tests themselves don't have grades on them. So y'all can just fumble through these and grab yours, all right? The thing that has a marking on it is the part that you did with your calculator. So I'll call your name on those. So I'm just going to throw these all on this table if that's all right with y'all. That's okay with everyone? Doesn't have your grade. Spread those out. Oh gosh. All right, y'all can come get those off that. Let's see. Maximus. Juliana. Where's Juliana? Alicia. Brandon. Brandon, that's you. Alicia, that's you. Chris. Natalia. There you are. Juan. Noah. Dalton. Gerardo. Stephanie. There you go. Tori. Andrea. And you can come grab your exams off this table. Alyssa? Sana? Go Matthew. Sana, sorry. No,
Is mine in there?
you should be down there. Oh, no.
It's not
I
there.
didn't. I'll take care of
Okay,
it tonight. Jared. Jackie. Let's see. Juliana, did I miss anyone? Oh, wait, hold on. Jackie. Maximus, right? Your exam wasn't in there? Juliana. Jackie. Am I missing anyone? Did I miss anybody? No? All right. We're good? Yes. Oh, let me turn off my camera.